Other? What's other?
Girlfriend.
Girlfriend. Very committed to the cause. I appreciate that. All right.
How many of you guys do data science for a living?
All right, welcome back everyone. So how's the session going so far?
Good.
Good? Enjoying?
Yep.
Interactive learning? A lot of it, right? Okay, I'm here to introduce our panel for interactive applications on Spark. So the first person I would want to introduce is Mr. Raj Babu, who is a CEO at Agilysys, moderator Raymond Fu, practice architect at Trace3 Founders, David Levenger, Senior Director, Information Technology at Paxata, and who's the next one? So, over to you, sir.
All right, thank you. Thank you very much. First, thank you for the organizers and the volunteers for putting this together. It's awesome. Been coming for the last 2 years. It's really nice to have something in the south. Too many things in the north. So I'm a CEO and founder of Agilysys. We are primarily focused on big data services and cloud-based big data services, Amazon, Google, and Azure. So I'm going to moderate today's session. And I would like David and Raymond to introduce themselves.
So I'm David Levenger, Director of IT at Paxata. Paxata does data preparation at scale using Hadoop and Spark. So I will be able to talk about how we took Spark and added a lot of the kind of secret sauce on top to make it a lot more interactive, sub-second response.
Hi, I'm Raymond Fu. I have 16 years of IT experience, mostly with data integration, data warehousing, business intelligence. And for the past 3.5 years, I've been mostly working in the big data world. Did a lot of projects in Hadoop and using Spark. And the company that I work for, Trace3, is a technology service provider company headquartered in Orange County. So if you guys in the SoCal area, maybe you've heard of it. And what we do is we actually have a lot of clients in this area, and we help them looking at the latest and greatest technology to help them bridge the gap, build the roadmap, build a business case, and eventually bring value to their business. Unlike those major consulting firms like IBM and SAS, Trace3 is actually vendor agnostic, which means we have the freedom to work with all kinds of vendors, so we can actually give recommendation of the best product to our clients and also build a solution on top of that and tailor to their business requirements. So that is why we have worked with a lot of the best technology companies in this area, and Paxata being one. We're actually invited by Paxata to come here to do this panel together with them, and it's a great opportunity. And we would like to talk about big data, Spark, interactive applications with everybody.
Great, thank you. So let's, I think, I'm sure some of you guys are already familiar with Spark here. They have even worked with it. And for the benefit of others who are more curious to know how it can help with them and the solutions they are developing in the big data space or analytics space, I'll start with it's more like giving a background. So can you guys briefly describe the Spark and in your personal experiences, what kind of values you guys have seen Spark deliver for the customers? What kind of really complex issues, which is otherwise difficult to solve with other tool and technology, that Spark is very good at addressing?
So when Paxata was first looking into how to build a data pipeline that we could use for interactive data prep, Spark was kind of the only option at the time that made sense. Their vision statement was very in line with our vision statement, which is we wanted a modular pipeline that could be scaled out horizontally on commodity hardware, because we knew we ultimately wanted to not just work with data, but we wanted to work with data at immense scale, and we still wanted that data to have an interactive component, right? We didn't want it to be the map reduce, run a job, and wait a really long time, and then come back to that job. So we started working with Spark before it was 1.0. We actually went live on 0.9 and then have been upgrading with them ever since. And it's enabled us to craft the platform that we have today, which can provide sub-second response, interacting with data at pretty much any scale, from millions of rows to billions of rows. And there was a whole lot of work that I'll get to talk about a bit later that went into building on top of Spark. Spark's an amazing platform, and we love Spark, but it doesn't magically solve kind of all of the problems for you. There's a lot of things that if you don't watch out for as you scale your data up in Spark, you'll end up running into situations where the interactive performance specifically lacks. And one other piece that's kind of unique to us is we deal with dirty data. We do not deal with data that is clean. We do not deal with data that is like already in the state you want it to, so you can just happily stream it through. Our product needs to let people interact with that data, find the problems, find the corner cases, find the needle in the haystack, right? The 3 million rows out of 1 billion rows that are wrong. And Spark was a tool that allowed us to do that interactively, at scale, while still providing all the things you need at scale, the resiliency and some of the enterprise features and that sort of thing.
Great. Just one question before we do that. When you said dirty data, you guys are very good. Can you a little bit dive deeper into that? What do you mean by you guys are good at it? Or even, you can, if you are familiar with that, you can address, because that's an interesting concept. Many people will be interested. What do you mean that you guys are good at dealing with the dirty data?
Sure. So for us, dirty data is data like you have company names entered in by human beings, right? So they're going to be misspelled. They're going to be spelled different ways. You'll have Microsoft and Microsoft.com and MSFT and Microsoft with an incorporated at the end. And when you try to do analytics on that data, you're going to get the wrong answers because you're going to have sales bookings that are tied to the wrong company, that sort of stuff. We get data where a column should only contain numerics and it contains text. We'll get date columns that contain everything. We'll get columns that are supposed to be only text and contain only numbers. And you end up with all this stuff, and if you try to analyze that data, you're not going to get the right answers. You're going to get the wrong answers. And then you're going to go back to the data, and you're going to try to figure out, like, well, how do I clean it? How do I get this data right? And the other part is that we allow you to enrich data. So you don't usually just want to work with maybe data you own. You want to work with data that's available on the internet. You want to work with data from other companies. When you don't own the structure of that data, there's no guarantee that when you get it, you're going to actually be able to do what you want with it. And so we help you work on that. And again, Spark being the path to achieving it.
I know this is a mixed audience here, so I'll just start from the beginning, the scratch. I think Spark completes Hadoop. Because Hadoop is, when we're looking at the business requirements that's data related, we always look at two things, storage and performance. Hadoop is a very good solution that provides a storage solution. It's cheap, it's very cheap, okay? But the original processing platform comes with Hadoop. MapReduce is just too slow. I don't know how many of you guys have used Hive that was before Spark. Hive is actually an interactive application. You have a screen where you can put in SQL statement, and then Hive will translate that into MapReduce and then dig into the data and give you the results. But with the speed of MapReduce, you cannot do good interactive work with whatever you have in the database, right? So and the reason is because MapReduce will store everything into the disk, and as we all know, reading, writing to I/O is very expensive. So Spark solved all this problem because it's pulling data into memory, run everything in memory, especially when you have very complicated queries, Everything is done in the memory until you tell it to output to whatever. So with Spark, we solve the business requirement of performance. Now we have a whole system that that gives you the cheap solution to store data, and now you also have a good performance platform that achieves the goal of getting, say, some kind of a real-time and near real-time solution. So that's what Spark is really good, and I think it completes Hadoop, and now we have a very good system that we can work on.
Great, thank you. There is one question based on that you said, which is not there in our list of questions, but I think it's very important to ask. Why Spark is very perfectly, is Spark a perfect solution, or there a better solution for data science and analytics? Well, if you guys think Spark is the perfect, as of today, in the current market, technology available, why you guys think so?
Well, I can say it's a perfect solution. It's one of the best. I can't think of anything else.
Because of the performance?
Because of the performance.
Because
yes.
in the other things, when you're doing the data processing, you can have time. You can wait for a workflow to finish. But when you're doing the analytics, you're testing, checking out something, speed is of essence, and Spark, if you want speed, there is nothing in the today's nothing even close to Spark. So Spark for data science is a perfect solution.
Yes, and I think
working from HDFS.
Yeah.
Is that you mean?
Yeah.
Reading from
Yes.
HDFS.
Exactly, from primarily the NoSQL technologies that side.
And I think the topic for today is interactive applications on Spark.
Right.
So if you want to do some interactive work on your cluster, then the speed is really important, because data scientists can't just wait, grab a cup of coffee, run a query, grab another cup of coffee, and that's not going to work.
Yeah.
And you can't iterate that way. You can't iterate through, like, I'm going to run it, and then I'm going to go get lunch, and then I'm going to come back and run it again. You need to quickly be able to change something, and potentially change something massive in its scale, and see the result, and then go, well, that was wrong.
Yeah.
And then do it again, so that you can actually get through a process quickly, versus it stretching out to weeks or months.
Yep, great, thank you. And what are all the lesser known issues working with Spark, but they are very important based on your experience that you guys think the people working with Spark should know?
Well, let me first talk about a better known issue about Spark, and then maybe David, you can talk about the lesser knowns. Memory management is always a problem with Spark. Everybody knows about it. And I like the comparison of writing Spark and building an airplane. Building an airplane is tough. It's hard work. You have to put a lot of effort in it. But once you build it, the next question is, can you fly it? It's the same as writing Spark. Writing Spark, especially for people who does it for the first time, there's a lot to learn, there's a lot of effort you have to put in. But once you get your application done, you write the program, you're going to put that into the yarn, it's the beginning of another story. You have to manage your memory really well, and there are just a lot of gotchas. And there are best practices. There are things that we need to know, but there's just no systematic guidelines that's out there for you to say, okay, we just do 1, 2, 3 and get the job done. So that requires a lot of experiences. So I don't have like a guideline for you guys, but I do have 2 advices that from my past experiences. Number 1 is when you're writing in development, when you're writing the code, make sure you write memory efficient code, because when you're writing standalone applications, if something is not memory efficient, if it runs, it runs. If you put it in production, it will still run. However, Spark mostly is running on a cluster with a lot of data nodes, and if it runs on a standalone mode with your sample data, does not mean it'll guarantee it'll run on the yarn with the production data. So that is really something we need to be careful when you write the code. Make sure you be memory efficient, because everything that's inefficient will be run on multiple nodes or multiple iterations. So keep that in mind. Another advice I want to give you guys is just plan, when you're planning for development, put aside enough time for performance testing, because this is really important. You want to make sure you test it really well with as much data as you want, and you want to set aside that time and let the stakeholders know, let everybody know this is Spark, we need these extra time to make sure things are working. And because you don't want to surprise them, because that will make you look really bad. So put aside enough time ahead of time and let everybody know and do a good performance testing and then deploy your application.
I want to ask you very, very closely related.
Go ahead.
So like, when you're thinking about building like a stack for production, and then you have production data in there, and then you have the development production data coming on machine or whatever, then you have like, based on what you're saying for performance testing, it sounds like you recommend like having just a staging environment just for performance testing, like where there's no development on there, there's just that kind of setup?
Yes, well, yeah, I do suggest that. I know a lot of companies that don't have the luxury to do that. I do see, actually, we help companies do performance testing on production. That's just a sad truth. But just, yeah, but you have to do it. You have to do it, making sure you do it, maybe do it off-peak hours, schedule process that's not in the normal business hours.
So we actually, we do performance testing on production data, but we don't do it on our production system. So we actually take a replica of production prior to any new release, and we run a whole series of perf tests against it. We compare those to the previous release, so we can actually look at, well, like last release, these projects ran at this speed. This release, they ran at this other speed. And then we quantify why. Like, why did that happen? Well, we made this change here, and that was positive. We made this change here, maybe it had an adverse effect. We found in the world that we work in, especially with like people anyone can put up any data they want, of almost any size they want, in any organization they want. How do you try to design tests for that? You can't. It's impossible. And they're going to do, by the way, whatever they want with it. One guy's going to do 500 find and replaces in a row instead of one computed column, because find and replace was easier for him, and that's what he did. So being able to use that data without looking at the data, because data privacy is hugely important, right? So like a way that we could perf test the data without needing to look at the data was something that we worked on early on, because you're absolutely right. If you don't perf test Spark, you're going to really regret it later.
Exactly what you just said. You know, we'll test the data without looking at the data.
You can't look at the data, and you have to be able to guarantee your customers you can't look at the data. And it's wonderful to be able to tell them, we don't look at your data, we can't see your data. We do use it as part of perf, and that occurs on the prod side of the world. So my team is the DevOps team. We're the only ones that have access to that side of the world. So that testing falls to us. We're not actually like manually testing it, but we run the process and we craft the output and we share that output to development. These projects changed in these ways. They had these types of data prep steps in them. What did we change in that world that can kind of quantify that? So I think it's really interesting that you brought up memory and perf testing. And when we were like talking about this beforehand, I was thinking, wow, I haven't had a memory problem in Spark in a really long time. But you're absolutely right that the very first thing you run into, and that's exactly what we ran into when we first moved to Spark, was everything would work, everything was great, and then we'd have a cluster problem one day. And we're like, what happened? And it'd be because somebody did some random step with the data that some developer somewhere thought, well, I mean, that should never produce a large result. We can just hold that in memory. And no, you can't. You absolutely can't. If you ever think to yourself, we can hold that in memory on a single node, you're wrong. It will, I guarantee you, I don't care how obscure or small you think it is, it will come back and bite you. And this happened to us probably for the first 6 to 7 months we were live. It was a nightmare being in ops. We were getting called all the time. We were getting woken up in the middle of the night. The cluster went down because the team in South Africa ran something, and I'm like, what are they doing? And then once you get past that and you get your developers to really think, like, assume you don't have memory. Figure out how you're going to store large data structures in a distributed environment where you don't have memory. Pretend you have no memory. How do you do it? All right, now optimize it so that you're not really trying to do that because it would be terrible. But figuring that out was really important. And then on top of that, we ended up, like you're saying, you have memory, you have CPU, and you have disk. Memory, CPU, disk, and network. Those are the things we're always thinking about, right? And if we're going to optimize something, we want to basically limit one of those. I mean, in a perfect world, all of those, right? Use them less. But in different specific cases, we'll try to limit different things. So we built a cross-session persistent caching layer on top of Spark. We had some very specific needs. Again, we're working with dirty data. We need people, when they're preparing data, to be able to go to any part of the data at any time. So you have a distributed system that's running across 100 nodes, and a fraction of that data exists on every node. And the person is in the UI, and they go, I'm going to scroll down here. And you need to return that section of the data that they're looking at to them in less than a second. So there was a need for us to build this persisted layer on top of it, where when people take steps in our product, those steps are fingerprinted, and you basically can identify that this unique set of criteria corresponds to this cache sitting over here. That's not to say we don't use Spark RDDs. Of course we use Spark RDDs. We did a lot of work at the RDD layer, basically trying to shorten chains. So I don't know how much, I mean, this may be too deep, but if you're some developers, it shouldn't be. In Spark, although Spark's very good at realizing it doesn't need data, so it'll read it and throw it out, read it and throw it out until it gets to the data it needs. Or sometimes you can even make it efficient enough where it doesn't read the data in. It still reads in the header of where everything is. And when you start to get to really big files, just the act of reading that header is really time consuming. So we ended up changing, we have application-specific RDDs that break these into smaller pieces, so we try to keep the chain as short as possible. Now, we're not going to keep it as short as possible sometimes. If it doesn't make efficient sense to cache at every single layer, we won't. So if you do a simple operation like to uppercase, we don't need to create a cache for that. We can do that on the fly, like literally as it comes into the UI. But if we do a complex operation, like a shaping operation, we don't want that shaping operation to have the tail of every operation that came before it. Or the act of rendering the shape takes all this time, when most of that time is really a no-op. It's just look at it and go, I don't need that, I don't need that, I don't need that, I don't need that. Well, to your point, on your computer, like when you're running it in dev mode, maybe it only takes 1/8 of a second. Well, now that 1/8 of a second needs to get applied across 1 billion rows. And guess what? That's a really long time. And that ends up being quite painful.
Great. I'm going to, so this question lines up very well with the previous one. Have you guys tuned for one thing in your experience, and that created, it solved that problem, but it created a few other problems? Can you guys throw some scenarios in the Spark, those kind of stuff?
Yeah, let me think. There are sometimes you have to change the business requirements because you're using Spark to process your data, and because of the performance is critical, you have to change the way you do things. One example I can throw out there is that for this one project, we're actually processing 1,000 files a day. Those files range from 100 megabytes to 300 megabytes. So we actually, the original design is we will have a Spark job that was scheduled every 2 minutes to pick them up. So every execution 2 minutes, a whole day is 720 executions. 700 executions, 1,000 files, you do the math. It's 1 or 2 files each execution. So we think, okay, that's pretty straightforward, right? So the way we process the file is we want to read each file one by one, and then read the data, of course, into a hive table, and then we want to do all the bells and whistles based on the file names. So because we already have some of the logic that's out there that will be triggered by the file names. So we process the file one by one. Now, later on, once we decide to put that in production, we come into an issue. Those files, they're not always coming at the one at a time. Sometimes there will be a gap. You will have 6-7 hours that there's no files, and then all of a sudden you have 300 files that comes in, and then it creates a problem because, of course, it'll. For example, it's 5 o'clock in the afternoon. Now we get most of the files coming in, and we only have less than 7 hours for that day to process all these files. And we realized that if we process those files one by one, we're not able to finish those jobs for that day. And that's going to be a problem. So we're trying to fine tune it. And we figured out an interesting, we found it really interesting is that actually we are using text file, Spark context text file. I don't know if you guys are familiar with that, to read the file, Spark context text file. For that method, you can put in one file name. You can also put in a wildcard to get all files within a folder. And originally we thought, okay, running one file is 1 minute. Running 1,000 files is 1,000 minutes, right? That's simple math. But we realized that if we run a wildcard and run those 1,000 files all at once, it's not 1,000 minutes. It's a lot less. You won't believe it. It's 10 minutes. So that was last year. We just started doing Spark. So we had to dig into this and try to do some of the testing to see where the problem is. So one file at a time, 1,000 minutes. All files altogether is 10 minutes. So we try to do something else. We were thinking maybe it's the business logic that takes time, because we are doing a lot of business logic in this process. So we decided to do one file at a time, but instead of running the business logic for that specific file, we do union RDD. So basically, we get 1,000 RDDs from 1,000 files and union them together and see the results. The results is improving, but not much. It's like 80%. So 800 minutes we completed those. So from all these practice, we realized that the main problem is that we have to read all these files together, and that will solve our problem, right? And then we dig deeper into this, and we realize that the reason because of the big difference of these is because it takes time for you to grab all the files from all different data nodes. So if you have one file, because think of it, HDFS, it's a distributed system. Even if you have one file, that one file has been distributed into multiple data nodes, say 20 data nodes. If you have 1,000 files, those 1,000 files are distributed into the different data nodes. So grabbing them one file at a time and grabbing them all together, the overhead is cut in majorly. So that's why you can complete the job in 20 minutes. So that is how we implemented the process. We use wildcard to read everything from that folder and then solve the business case. And to go back to your question, because of this, we have to change of course, logic. We have to, because we have to archive those files and do a gzip. So of course, we have to use another different process to make sure all the files that's being processed are zipped up and sent somewhere else. But this is something we realize in real world use case that we find out this problem, we solved it, and it's impacting the business, but I guess it works in the end.
I think almost every time you optimize one way, you have side effects you don't expect, right? Very early on, we thought it would be more efficient to transmit less data over the network, so we compressed it before we transferred it. Turns out, no, the CPU cost far outweighed the compression. It was way better to just transmit it uncompressed. Other cases, that would probably not be true, but in the cases we were running into, we tried it one way, and that goes back to the perf testing. We tried it one way, and we said, oh, it'd be way better if we did it this way. And we tried it, and we went, that took longer. Why did that have taken longer? We looked into it, and it was because we ended up slamming the CPU. Spark did a lot of work to make it so that you don't have to depend on memory as much, right? So they can spool things out to disk, which means your disk I/O is non-trivially important. So a lot of times people will think, oh, I'll save memory, I'll write it more memory efficient, it'll spool it to disk if it needs to, and then you end up in a situation where you're like, why is this so slow? I don't have a really fast disk, and that ends up being a problem. Our caching layer ran into that where we're caching all this stuff to disk. The nodes can retrieve caches from other nodes, so we ended up in situations where you might end up having one cache on one node that all the nodes needed to look at. and then all of a sudden the disk on the one node that's serving that cache up is just utterly destroyed, right? So we had to completely change how we do many-to-one cache retrieval to understand, like, look, if you get a request for this cache, wait a split second, and then serve it to everyone asking for it at once, versus trying to field 1,000 requests from 1,000 different things asking for that cache. So there's efficiencies that we built in there. Trying to think of just the ones I can think of off the top of my head. But you always have to think about, like, all right, well, if I fix the performance issue here, where does it go? That's actually true in perf testing as well. A lot of people, when we're working on perf testing, they're like, we need a really huge Hadoop cluster to do perf testing of our app. And I'm like, we're not testing the performance of Hadoop. We need a big Spark cluster, because we are testing how our app runs in Spark. But the aspects of reading data from Hadoop aren't necessarily the right way to test the performance in Spark. So we actually crafted a process where we data gen in Spark itself. So we can actually say, construct me a file with these dimensions, with this cardinality, with these types of data and these types of columns, and then join it with a file that has a 3% match, blah, 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 lots of data prep terms, so that we can purely test how does it perform in Spark. And Spark does data gen really, really well. So rather than like trying to build something outside of Spark that I store in Hadoop, that I try to pull in and I'm waiting for the Hadoop piece of it, to your point, we said, well, wait, why can't we don't care about the Hadoop piece, it's a separate problem. We want to know how the interactive stuff works inside of Spark. And so actually building that in Spark and then testing it in Spark was more important. And we can do that because the penalty you pay in what we do, getting it off Hadoop is time consuming. What people do with our product is very iterative. I'm going to bring the file in, I'm going to do something, I'm going to do something, I'm going to realize I did it wrong, I'm going to go here, I'm going to come back here. It can take people a very long time to construct a project end to end, depending on the complexity. So all those things need to be cached, which means once the cache is in Spark, we're not reliant on the HDFS side, the storage side anymore. So everything that we do in Spark is a cache. You take metadata and the originating data from Hadoop, and you end up being able to reconstruct that pipeline in Spark, which means the data in Spark is ephemeral, it's temporary, we don't care about it. You lose a Spark node, lose the cache, we just regenerate it, it doesn't matter. But it means we can focus our perf efforts in Spark and not be perf testing how Hadoop runs, because that's one, not necessarily the problem space we're trying to solve, and two, you can end up really focusing on that side when what you should be focusing on is how does your app perform.
Great. Yeah, that's an excellent point, because usually, it's a bad design, which, we will figure it out most of the time in the beginning stage, even before it goes to production, or it's a bad code, or inefficient code, which also you will figure it out. Really, most of the times you work with the third option, which is reprioritization. What you can, push it to the other side, and what you have to put in the front, like the files and all that stuff. It's looking at prioritizing, which helps, definitely in the overall performance. That's one. Before we go for more resources, that's the third thing we can try. The next question I have is, how is cloud playing into this? What is the cloud's role? What you guys have seen? So throw some light into Spark. Let's go.
Sure. Cloud is very important. Cloud is very popular, and I would recommend cloud to everybody. Trace3, actually, we have a cloud service, specific cloud service that is different than the data intelligence department, which I'm in. But what we do a lot of work is in cloud as well. And I think, the reality is actually most of the clients for the data intelligence team are on-premise. But whenever we approach a new client with a proof of concept solution, most likely we have that cloud in cloud. Our preferred cloud service provider is AWS. So it's very easy to create a cluster of 4 data nodes in AWS and build your Spark application on top of it, and then it's easy to redeploy it to a client's account, and then you can show the results right there. So it's very straightforward. And also something else that we use a lot is Cloudera. Cloudera is also our partner. They have an enterprise hub that is very easy to deploy in AWS. and then you can easily deploy it. So if you're doing this as a hobby, or you're trying some proof of concept for your work, instead of dealing with the admin to get access to your cluster, you can easily just get it from AWS and then build it up there, and then it'll be plug and play. And then once the concept is proven, then you can talk about the next level if you want to expand it to a full-fledged clustering cloud, or you want to move that solution to on-premise. And I think Paxata is really expert in cluster in the cloud, so you probably have more to say, David.
Yeah, so one of the two ways you can consume Paxata is in the cloud. We have a cloud distribution, so my team runs that. We're in AWS as well, so we have a Spark cluster, we have a Hadoop cluster. Everything you said is spot on in terms of the benefits, especially if you're a hobbyist or you're exploring. Spot instances in AWS feel practically like you're cheating. It's amazing. They're 10x less the cost. The risk is they disappear, which is something to keep in mind when you're designing your app. And something that I brought to development over and over again was like, look, we can't rely on the resources being there, or cloud probably isn't really our best play, right? But if you can get away from having the resources available all the time to thinking about like, well, how can I have these resources only available when I need them? Now the cloud is exceptionally interesting. So one way we leverage that is in being able to say yes to our customers. So we have customers that, on average, are processing 10 million row files. They're not very big. So they can use a tier of our product that's not that expensive. And then occasionally they're like, hey, I want to process a 500 million row file. Well, obviously that's a order of magnitude difference, right? So being able to say, that's sure, when do you want to do it? Like, we can bring resources up. You can consume those resources through our product, and we can destroy those resources when you're done. Make cloud an excellent way, especially when you're doing data where, look, your storage system, again, separating out the HDFS from the processing side, your storage system needs to store that data, needs to stick around, right? Although in the cloud, of course, you can persist it to S3, but it needs to stick around. The processing layer, why is it there if you're not using it? There's no point. So I understand the originating, some of the originating concepts in Hadoop, right, was, you bring you co-locate your data and your processing, you move less data around, but to something I said earlier where we realized, like, actually the data movement isn't as much of the problem. So being able to have that processing separately and being able to spin up like a massive cluster for folks to use for a day and then destroy it all is huge. And on the dev test side, it's even more beneficial because we can make use of Spot. And like I said, it's 10 times cheaper. You can run, we ran it was 1,000 core cluster for, I think it was 2 days, all on Spot. We never lost the instances. It ended up costing us like $60. Like, it was so cheap that it was like, you just try stuff. Like, I don't know, let's just see what happens when we spin this really huge thing up and do stuff. So going to performance testing as well, it's phenomenal. Bring it up, run a huge perf run on huge volume and destroy it. But you have to be able to have that rapid, I can automatically deploy it, I can destroy it, because if you leave it up, then you're paying for it. When you're outside the Spot, that can add up very, very, very quickly.
And the thing is, cloud very well works for that, because in your data science you have a use case, and most of the time you're trying it out, and it's not like a workflow or a job which is scheduled, which is in production, which is running all the time. So you need to have the system, or it's not a reporting environment where somebody is running the reporting, so it has to be up and running. This is purely data science and analytics. In that, it works very well because you can put it, spin it up. You can, until you finish your use case, you can have the entire thing run. And once you finish your use case, get your extract, put it in S3 or whatever cloud environment, and then you can shut the whole thing off. And that is more, easy, and you can justify this with the management because the cost for the kind of analytics you are doing is very well justified. It's very highly valuable, and you can run as many use cases you want. If you have a very big complex use case, you can spin up things as needed for that. And if you have a very small use case, you can spin up. So it's totally elastic, and you pay only for what you use. And you don't need to wait for the capacity, somebody in the data center to provision it for you. You can go, just get that thing capacity, use it, get it done, put it, get your output. If you're happy, if you want to refine it and do it one more round iteration of it, go ahead, get it done. So it gives a lot of flexibility in cost and elasticity in the capacity. So I would very strongly encourage cloud, especially for data science and stuff like that.
Spark works very well as well on the cloud.
Yep.
I use it all the time.
So what is the next big thing in this direction? The data science, Spark. Are there other things you guys are seeing that you guys would like to talk about?
Well, next big thing, I guess everybody has their own opinion, right? So, well, one advice is you already look out there, and there are always something new. There may be like just another Apache name out there, but tomorrow it'll be the next big thing, right? So, nothing will be like a fancy as Spark, right? Spark is like the Pokemon Go of software, data software. It's just out there and it's popular. But next big thing, at this point, I don't know. But one thing I want to talk about is actually something that people always look at Spark and say it's not the perfect solution. Is Spark streaming? As many of you may know, that the streaming in Spark is not real streaming. It's actually small batch jobs. What is real streaming? Streaming means we get all kinds of messages. You get one message, it triggers you to take some actions and get the message away. That's real streaming, one at a time. But Spark is actually not doing that way. Spark is actually, Spark streaming means it's scheduling the process frequently enough so it'll get the messages taken care of, but it's not a one-to-one relationship. Sometimes when even if you schedule like every second, sometimes there will be more than one messages that comes in, then you have to process in a small batch. So that's just the way it is. So a lot of people say this is not real streaming, and if in the situation that you really need to use real streaming, then Spark will not be the right solution for you. So I actually was doing a lot of streaming work in the past, so I was looking at all the latest and greatest, and I happened to notice something called Apache Apex. This is started only last year, and it was all incubating right now. But it's doing it's learning a lot of the good stuff from Spark, but it's doing real streaming work, and it makes data ingestion a lot faster. And the major contributor behind Apex is DataFrame. DataFrame is actually a company based in the Bay Area, and they're doing pretty good. And you guys will probably hear about them more often. So just watch out for Apex if you are doing streaming job. It's getting the name out there. You will hear more and more about them. And then, just to say, come back to Spark, I was saying that I don't want to say Apex is better than Spark. And I just recently looked at the Spark 2.0 release. I don't know how many of you guys have noticed that actually 2.0 has a lot of upgrades. And one of them is structured streaming. What is structured streaming? Spark is not changing the way they're doing streaming. It's still small batches. But what they're doing is they're actually looking at the big picture. When you're doing streaming, you're not just processing the message. A lot of the times you're actually applying complicated business logic to the message, and then you want to make some decision, predictive modeling, right? So you guys probably all know Spark machine learning library. A lot of times we use Spark MLlib to create the model, and we run the incoming data through that model, and then come out with a decision. So that is, and a lot of times the model will need constant data ingestion, and that is actually a batch process. And because Spark is a small batch process, they can easily make the whole process easy to to integrate the streaming process and the batch process as one process. That will work really well if you have data that's streaming in and then you have to apply some modeling on top of that. So kudos to Spark. Once I look at that, I think they did look at the big picture. They know what enterprise want, and I think this is a good solution that works for a lot of the use cases.
Yes, streaming is definitely something we're looking at as well. Same type of thing. Lots of people ask for it. A lot of people don't mean streaming when they say streaming. They actually mean what Spark has. They mean micro batching. So I always try to ask, like, what are you really trying to do from a streaming? Like, we had one company that wanted to. They're like, can we submit one row to you guys and have you do all your transformations against it and then send it back to us really quickly? And I'm like, yeah, we can. That's not really streaming data. That's like being able to quickly turn around like one row of data. And yeah, we can do that. We could even, if you want to submit 3 of them at the same time, that's fine too. We can do it however you want. But very rarely do I actually get someone that gives me a true streaming case, but we know it's coming. And Spark micro batching, if you need true streaming, Spark does not have it. It does not work that way. You can fake it in lots of clever ways, like being able to run a bunch of those micro batches in parallel, which is what we do. So if people want to submit, 50 jobs simultaneously with really small, even if it's just one row of data, that's fine. You can do that. Spark will run them all in parallel. They're separate jobs and spit out answers to you. But it's not true streaming. So we're definitely looking at that. We think data frames are really interesting, especially if you're dealing with non-dirty data. So we're not sure exactly how we'll be able to use them in our world. But outside of that, we think it's really interesting. So if you aren't dealing with dirty data, data frames is definitely something that I would look at. They're doing a lot of enhancements related to data frames. It's something our team's really excited about, but we're kind of like, how does that fit into dirty data where we can't really rely on it being in a functional, useful state? So we're definitely looking at that.
And in 2.0, the data frame, data set, they're making them look more alike. So it'll be, programming will be a lot easier.
Great. So just before we go to the questions, audience questions, what is some of the most interesting in your projects that you guys personally felt was a lot of value that you guys have done for customers, your customers, that you could share using Spark?
Oh, sure. Yeah, I got a couple of use cases. My background is a financial institute and the telecom. So they're traditional industry. We don't have any fancy Netflix type of use cases to share. So it's boring companies, as most companies, yours, mine. Anyway, I want to give you an example of a financial company that I work for, financial services company. They actually collect information from the ATMs and then build reports, and then those banks, they need those reports to do their work. So that's what this company is doing, and they have a process that's been out there for years. It's written in PL/SQL. It's on Oracle and works fine. But business recently changed. They have to change the reports. That means they have to rewrite the PL/SQL code. And I think the information I got is that person who wrote that code has retired like 5 years ago. And it's really hard to find any good PL/SQL developers recently. So they come to us and ask us to pour out some miracle. And we look at this process and we try to look beyond what they want, and we actually come up with a solution to them. And we tell them, why don't we just move this whole process to Hadoop and use Spark? And at first they were like, why? The data volume is not that big, okay? So there's truly not an urgent need for storage. Like I just said, storage and performance are always the pain point of business. So we have not hit their pain point yet. So they're hesitating. Then we tell them, if we are going to do this solution with Spark and Hadoop, there are a couple of things that we can do. Number one, we will rewrite this code with a more modern language. We decided to use Java for Spark for them, and it's a lot easier to find Java developers in this world, right? So they can have a better code, and the code will be better maintained. That's actually just a small advantage. The bigger advantage is that I know this financial services company, they're only servicing this reporting to one of the clients, one bank. We're telling them, okay, if we are going to make this, get this into a Hadoop, then you can actually make this a service and sell this to the other banks that you guys are serving. So that way, we're actually creating a business case for them. That's what we do. So this is something that we can help them to generate value for their process. So eventually, we did it that way. And I can give you a structure. I don't have a whiteboard, but I just use my hand to draw it in the air. The solution is actually HBase in the bottom. All the data will be stored in HBase. The data is actually sent to us by vendors from that pulls information from the vendor, send it to an edge node, and then we have Spark to process the files that were sent to us on the edge node and send it to HBase. And on top of it, HBase, we have a Spark framework layer where it creates an API that will take parameters and then pull the data out of the HBase. And then we build a web portal for them. This web portal where the business analyst can use some simple drop-down boxes, text boxes, key in those parameters, and pass those parameters into the Spark API, trigger the Spark job, and then get the results from HBase and display it on the website. So that is a solution that we gave to them, and they're the bank that used this process is very happy, and now they're putting authentication, authorization on top of that, making it a multi-tenancy solution, and they're actively selling it to their other clients. So that is how that is actually we're making a simple BI process into a real interactive application that can be used for a lot of more users and bring more values to the business. So I guess you probably have more examples like this.
So I'm gonna try to come up with really cool things like fraud detection and visa analysis for catching terrorists, and it all comes down to the same thing though, really, which is the interactivity and being able to look at the data now, not look at the data a week from now or a month from now, right? So we had a company that was running a coupon code thing, and their original process outside of Paxata took them weeks to come through all the data. It came in through all these different websites. It came in from retailers. It was in a bunch of different formats. It was extremely hard to deal with. So they only analyzed it after the fact. So they switched to using our product, and they were being able to do it very quickly. So they're like, great, we can do it quickly, we'll do it more frequently, right? So being able to not wait so long before you do it, but being able to do it right now. And so they said, well, why don't we just use this new marketing campaign that we're doing this coupon stuff, and we'll take a look at it. We'll see what data we can get out of that. So they did, and they're like, there's no way there's that many coupons being redeemed over here. There's no way there's that many coupons being done over there. That's impossible. It's impossible. And we're like, I don't know what to tell you, that's what the data says. Like, I mean, we're not making it up. Like, that's the data. And they realized that someone had figured out how to game their system, was generating all these fraudulent codes, and then immediately submitting them and getting a check. But because they were doing it now, they just canceled the payment. They're like, yeah, why would we pay them? This is obviously fraud. We can tell it's fraud because we can analyze the data quickly, and we can look at it now and figure out, like, no, that's really a problem. The visa analysis was the same kind of thing. It takes a really long time sometimes to do all the analytics when someone's coming into the country about where are they from, how does it work, what's going on, and that time gap is sometimes very scary. So being able to instead be able to take that massive amount of data, because believe me, the government has massive amounts of data, and being able to look at that data in real time, being able to manipulate it, being able to explore it, being able to figure out, like, oh no, this is something we should look at, or, and I think just as importantly, being able to look at something and say, no, this is fine, everything's fine, right? We don't need to worry about that. But when you're in a time crunch, when you're trying to figure that stuff out, and the process to do it based on the data or based on just access to the data, when that takes a really long time, then you miss those opportunities, right? You miss opportunities for finding fraud. You miss opportunities for finding the right people or the wrong people. And again, financial institutions use us a lot, same type of stuff, right? Finding audit events, finding that data now. I think needle in a haystack is another one. Because Spark can be made to run so quickly, you can end up looking at more data than you would normally look at. So when you try to build a process and you aren't looking at all the data, you're going to miss things. Well, when you can't look at all the data, you do the best you can. You look at parts of the data. And then you miss things, right? So working with 1 billion rows of data where you have 3 million bad entries, 3 million sounds like, well, that's a lot of bad entries, but when you look at that, that's like less than 1% of the data. It's a tiny amount of the billion rows. It's tiny. How do you find that? So giving, again, the speed, putting that on top of Spark, building that so that people could interact with it and find those like needles in a haystack, end up, being able to call out like, hey, these 3 million rows look wrong. Can we send that back to the group that sent it to us? Maybe it's fraud. Maybe it's just an honest mistake. Maybe they sent us yesterday's data and they meant to send us today's data, but we wouldn't catch that until it was so far downstream. There's all these problems that have cropped up out of it. So almost all the problems we solve, the ones that I think are the most interesting, are the ones where, God, this used to take us weeks, now it takes us hours, which means we're more willing to do it. It also means less people have to spend their time doing it, which is an additional business benefit, but doesn't sound as cool as fraud or
Great, awesome. I think, one comment I'll make and then I'll open to audience. What David, you mentioned for the streaming is true, because actually when people talk about streaming, they're really talking about processing transactional data in a very high velocity. That's what they're talking about. But truly, if you want to know this, really what is streaming, and I was at the Hadoop summit last year, and I think one of the security company, Norton, or there was this guy, the CTO from there presenting. They, before the attacks come, which for their clients, they do it so fast. Even before it comes, the attack is made on the client's network, they detect and they will send the information to the client, you have an attack coming your way. So the attack started from the source, and you know how fast this network. By the time even it ends to the destination, they notify the clients on the destination telling, there is this attack coming from here, this is what it is. So that's speed, that's streaming. So with that being said, I'll open the floor to the audience for questions. Any questions?
Have you used any graphics in your use cases?
Well, we did talk to one of our clients about use graphics, and they are, I can't say the names, but they're a financial company. They're trying to use graphs to do stock recommendation for their clients. So yes, so that we have a POC project that's going on with that. And I think GraphX is very good for this kind of recommendation engine, and I think Facebook is also using it because your friend is doing something, then I think you probably want to do the same thing. So it's the same thing. If you, in my use case, if this stock is this person with this background is doing this kind of invest in this industry, you probably want to do the same thing. Go ahead.
We'll go on time series data.
Time series data?
Yeah.
What do you mean?
Data is based on time, order times.
Do you mean do we process those files?
Do you do any algorithm based on data that have to do with time in Spark?
We basically all the process. I would say all the process we do, the data comes with a timestamp, and and the reason we use this Spark is because it's time sensitive. So I don't know if that answers your question.
Yeah, we do. Obviously, dates is one of the formats, and time's a part of that. We definitely do a lot of analytics on it. A lot of people will use it as one of the areas where they want to clean stuff up. They want to look at specific times, or they want to look at correlating events between times. So we provide ways that you can do that. So we do end up doing that on Spark jobs for sure. But not, some people really want like really complex time series stuff to like generate, this person came in and where did they go and what did they do, and time is actually the the center of the world for them, right? And that's not our focus. Our focus is the data as a whole. So you can do correlation, and people do. But if you're looking at like really time series specific stuff, then I know you can do it in Spark, but I don't have a lot of experience.
I have a potentially kind of like naive question, but it's about memory performance. So we're currently building applications for our cluster, and like if we have a job, a batch job, and a couple of them that we define in memory, and we have some streaming jobs in memory. Like, how do you think about having all these submitted, and you have streaming processes and batch processes, and optimizing and thinking about that memory management?
So that's hard. But I'll just start there. It's hard. Our use case is a little bit different than what you're describing, but in some ways, I think it's also a little bit similar. We have batch jobs that will run, so people can schedule automated processes in our system. We have no control over when they schedule. And then we also have the interactive piece, and we have no control really over when people are doing the interactive piece either. So memory management for us is extremely challenging as well, because at any given time, anybody can pretty much do anything. What we ran into with Spark early on was we were allocating too much memory to Spark, and we realized that we should actually be allocating less. We should allow the operating system some leeway so that when massive amounts of stuff come through, we don't end up in a situation where we thought we were managing everything perfectly, but in fact we weren't. So our error originally was trying to make the computation too accurate. We realized that we should find, again, going back to performance testing, find where it performs the best, and then figure out how we can have a high degree of these things running at the same time, and then kind of step back on the memory allocation so that even if accidentally a bunch of stuff hit at the same time, the likelihood was very low that we'd overwhelm the memory on the system. So that was one, and I only think the other one would be that Spark does have some really interesting, which a lot of people don't know. A lot of people think about resource allocation from the yarn level outside of Spark. And Spark actually does have resource allocation inside Spark, which is Spark pools. And you can actually balance things inside of Spark using pools and figure out like that this should be prioritized above that. It will actually take, new requests that come in will have access to less resources because something else came in that needed more resources. You can have the concept like we do of batch jobs versus interactive jobs. So streaming may need to take a higher precedent than batch. So while a batch job is running, if you break the batch job into small pieces, so it runs a piece and it completes, and then it runs the next piece. If a streaming job happened to come in at the same time, your batch job can be automatically deprioritized by Spark. Your streaming job gets more resources, your batch job will continue to process using less resources, and then when the streaming job finishes, the batch job gets more resources. So that's something that sometimes a lot of people don't know you can do actually inside of Spark.
So it will be part of the Spark programs that we write, or is it like through Spark configuration that we do?
So there's a Spark, sorry. It's Spark configurations. When you submit your app, you can describe basically how many pools do I want, what are the resources, how should those pools be balanced against each other, blah, 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 blah. The challenge is it's only when the app's submitted. So for an interactive app like ours, we had to think about how do we guess what needs to be done in advance. We actually created an abstraction layer on top of that, which we call tiers, to deal with that particular problem of the app being long running, but us needing to have a variable amount of pools and balancing between them.
Great. We are out of time. If you have any further questions, we speakers will
we'll stick around.
Yeah, for sure.